Since sine and cosine both have this waviness to them, we can think about critical points and use them as a way to sort of graph these accurately, because we know how many times sine needs to peak out and to bottom out in the course of one period, and we can sort of exploit this fact to draw an accurate picture, even if we're not sure maybe what effect a transformation is going to have and where, or exact trig values for specific points. So, to figure out where critical points fall, you can divide the period into 4, because we know that picture sine, it goes up and then it goes down and then it comes back up in the course of a period, and that can be split into four divisions, and after each division it's doing something important, like it's peaking out, or it's bottoming out, or it's crossing over the x-axis. So let's think about y equals cosine. Now the period of the cosine function is just 2 pi, which would mean that I have an important point happening every 2 pi divided by 4, or every pi halves. So every time I go pi halves along the x-axis, I expect something important to be happening to the function. So let's draw a graph, and let's make a table of values and evaluate cosine of x at pi halves, pi, 3 pi halves, and 2 pi to see if indeed we manage to capture those important points. Alright, ignore the blue function for now, and let's look back up. The cosine of pi halves is 0, cosine for pi is -1, the cosine of 3 pi halves is 0, and the cosine of 2 pi is 1 again. So if I graph these points and connect them, I get a good-looking parent cosine function. Now let's use our critical points to decide where some judicious places might be to evaluate cosine of 1/2 x in order to draw an accurate graph without expending too much effort. So, I know that the period of cosine of 1/2 x is going to be 2 pi divided by b, or 2 pi divided by 1/2, which is just 4 pi. So, if my period is 4 pi, then I'm going to have a critical point happening every pi, because that would be, 4 critical points in 4 pi. 5 if you count the one you start with. Alright, so I think if I put pi into this equation, y equals cosine of 1/2 x, then half of pi is pi halves, and the cosine of pi halves is 0. So for the input of pi, the value is 0. Now I put in 2 pi. 1/2 times 2 pi is 1 pi, and the cosine of 1 pi is -1. Now I can't graph any further because I have not extended my graph. But as you can see, the effect of multiplying x by 1/2 seems to be that it's stretching out this cosine graph.